Hello, let's go over enums in this video. Enums are a good way of grouping data together when they're related. What I mean by that, for example, is say we want the user to pick a certain color. Well, we have multiple colors such as red, green, blue, and so on. This data can be grouped together because they're related. An enum is kind of like a type, such as an integer, and somewhat like an array, but it's different from both. It holds data of a certain type, like an integer, and has multiple values, but those values are not necessarily indexed like an array. Let's look at a code example to see what I'm talking about. So I'm going to go ahead and create the enum colors. And so what this does is it creates an enum called colors that will contain the value red, green, blue. And so what an enum is as I said before, it's kind of like a type and kind of like an array, but it's different. So what I mean by that is when we say we want an enum colors with red, green, blue, what that really is saying is that we want an a grouped number of values. When you look at these values in here, you can think of these as actual just values instead of just red, green, blue. These names don't actually mean anything. What they have is what's called an underlying type. And so what an underlying type is it's kind of like a type like an integer or a double or a char that you can't necessarily see. It's inherent. The compiler automatically gives each of these, what are called enumerators, a type. In this case, by default, C++ will give an enum, in this case colors, an underlying type. And so what that will look like by the through the compiler is with a colon int. All right. And so what that does is it gives each of these values or each of these enumerators a type of an integer. So it would be kind of like the same as saying int red and int green and int blue. But here's where the difference comes in from the from when I said that it's kind of like an integer value. The reason why it's different is because here where we have red, green, blue, these are uninitialized. These will not these don't have an actual specified value, but these do. And the value that these will have is based on when or where they're listed. So whenever you start with the first enumerator, if you don't give it a value, it will start at 0. So in this case, red has the value of 0, green has the value of 1, blue has the value of 2, and if we were to put another color after blue, it would have the value of 3. And so if we were to actually start with, for example, 10, then that would mean that green would have the value of 11, blue would have the value of 12, and so on. The values of your enumerators are automatically initialized. That's why they're different. That's why they're different from just normal values, or rather normal variables. And how they're different from arrays is that if we want to access sort of red or green or blue from colors, we don't need to type the index operator, the square brackets, like we would with an array. We don't do colors and then index and then 0 or 1 to access green or 2 to access blue. We don't do that. We just type in the enumerator. In this case, if we want to do red, we would do red or green or so on. So that's how it's different from an array. I'll go ahead and delete these. And so what do we do with these? Well, what we can do, for example, is let's just say we want the user to pick a certain color. And then we print out that color. So let's say pick a color from, let's just say 1, 2, or 3. Because we start counting at, actually, you know what? Let's go ahead and change this. If we don't want to start counting at 0, we can actually change it. All right, we can change it by doing equals 1, and then green can be equals 2, and then blue can be equals 3. So remember, these are just are like values. They have a value behind them, and so what the compiler will see is it won't, when it sees the enumerator, it won't actually see red or green or blue. It'll see the value behind it. This is how it's kind of like an array. It won't look at red or green or blue. It'll just look at 1 and then 2 and then 3. The red, the green, and the blue, that's just for us as humans to be able to more easily read it. The compiler will itself look at the numbers rather than the title or the name that we, the programmers, give it. All right. So that's how the compiler will read the enumerator. So let's go ahead and turn a number from 1 to 3, and using good int user input, just go ahead and give it that name. Using good SDCN practice, I'm going to go ahead and check for continuous, or I'm going to do a continuous check to see if our user is entering good input. So CCN user input. And so again, if you don't recall, what this is doing is we'll continuously take in user input through our while loop right here, and we will check to see whether it's good or not, which is the purpose of this not operator right here. If it's not good, then we want to clear the fail bit, and then we want to ignore the last, let's just say 5 characters up to the enter key. All right. So again, this is going to continuously take in user input as long as the not operator passes. So this is what this is going to do, is check whether the user inputs a good number or not, and then if it's not good input, we're going to clear the fail bit and then ignore the last 5 characters of the buffer up to the new line character. And so now I'm going to do a switch statement that will jump to the specific value depending on what our user enters, and it's either going to be red, green, or blue, or by default, if the user enters in a different value, we're just going to say we don't support it. So we're going to do switch user input. I'm going to do case red. I'm going to do print that the user picked red. And then I'm going to do the same for blue, or green and blue. You picked green, and break, and yes, I know, forgot end of that, and then the end of the line, got the colon, and then I'm also going to do case blue. You picked blue. And then break, and then the default case. Color not supported. That sounds about right. And then we don't actually need a break on our default case. Yeah, that looks about good. And let's just go ahead and run this and see what we get. So pick a number from 1 to 3. And again, I'm just going to go ahead and I didn't put any error output in here. So if we type in, for example, F, we're not going to see anything, or E, or just G. We're not going to see anything again because I didn't put any output in the while loop for if our input fails. So I'm just going to go ahead and pick 1. And then as you can see, you picked red. And so again, the reason why this works is because these titles, these placeholders, they're not like a string or a char array or anything like that. Again, they're just a placeholder for a value. So we could very well just replace case red with, for example, just 1, and then green. We could replace this with 2, and so on. So again, the enumerators themselves are just placeholders for values, and that's the whole point of enumerators. It's to group data together, and then you give them a placeholder name or title, such as red or green or blue, and just again and then they have an underlying type, in this case an integer by default, which gives them a value which increments based off of the pattern or the way in which you line them up. And so again, if we want to know the truth, if we could only put if we wanted to, we could only put 1 here, and then green will automatically get the value of 2, blue will automatically get the value of 3. So in this case, if we wanted to do, we could just do this and then delete this, and that'll pretty much be the same because we started off with 1, and the enumerator's value will increment by 1. The compiler will automatically increment these values by 1, depending on what our starting value is. So it'll be 1, and then 2 will be for green, 3 will be for blue, and then this will also be the same for example, if we wanted to do blue, and then if we want to do yellow and then orange. Just say if we want to do 1 and then we just said blue was something crazy like 10, then yellow will automatically get the value of 11, and then orange will automatically get the value of 12. And so that's just another thing to keep in mind when you're working with enumerations. And so let's go ahead and actually look at another way we can use this enumerator. So the thing to keep in mind with enums is that these values can be used anywhere, in any different kind of function or anything within this file. So it's important to keep in mind that that you don't want to have these values just being used everywhere. Otherwise, that could cause some problems. If, for example, we have another value named green or another value named blue, and so on. And so it's important just to sort of keep these confined. And so what we could do is, instead of declaring this, because as you can see, this is only being used by the main function. So what we could do instead is, sorry about that. We could just instead use or put the colors enumerator inside the main function as so. And then give red the value of 1, and then we have done pretty much the same thing. We are also able to do this, and actually this should be the preferred method that you should use if you know that your enumerator is only going to be used in one function or in one specific place, just because it's safe. You don't have to run the risk of, for example, if you have another function that has the value red or the value green, and you're assigning that value, then you may accidentally get a sort of different value than you intended. So it's important, just if you're using an enum that is only being used in one place, just go ahead and put the enum in that one function, just like I did here. It will work the exact same, and you will just be writing a bit more safe code than if you put it in if you put it globally outside of any function. So it's just another thing to keep in mind.